In this video, we're going to learn how to use a decision matrix in order to help you figure out what are the best options for a design solution. How do you develop a decision matrix, and what is a decision matrix? A decision matrix is used to compare design solution against one another using specific criteria so that your bias and what you think might be the best design stays out of it. That sometimes you have your design and you really like your design and you want to build it, but it may not be the best solution for the time that you have or the materials you have available. And so the decision matrix really helps you to figure that out and make your decisions and stay unbiased. It's really just like a survey. Like you're taking a survey of different people and you're ranking them, and you're gonna add them up in the end to figure out which one is the best solution. So let's practice making one here, and let's decide what materials would be best for creating the models of our puzzle pieces. So we have several different designs here. We could use dye, or we could use modeling clay. We could use these interlocking centimeter blocks. We could use sugar cubes, that would be fun. Or we could use caramel. I love caramel, that would be tasty alternative. Or we have the 3/4 inch wood blocks that you've already been working with. So what are some advantages to using model clay? Well, it's reusable. It's readily available. A disadvantage is that it does require some forming. It comes in these little tubes and you have to make them into the cubes. They are sticky, so they'll stick together when you put them together, but a disadvantage is that they are imprecise geometry. It would be very hard to make all of your cubes exactly the same, and in trying to do so you would use a lot of time. How about caramel cubes? They're very cheap and they're readily available this time of year. There's lots of caramel out there. They are already pre-shaped, so it takes care of the disadvantage from the clay in that you would have to make the shapes themselves. They are sticky so that you can still, if you unwrap them, you can still stick them together and they would hold your form. And then also, but they do have imprecise geometry, and squeezing and moving them when you unwrap them, they're not all exactly the same size or exactly the same shape because they could get melty and distorted. How about dye? Dye would take care of that. They have very precise geometry, and we could use them to represent the same shape and put them together to make puzzle cubes. That would be a neat solution. However, the disadvantage to dye is that they're expensive. In order to be able to buy 27 dye, that's going to cost you about $25 to $30. And then if there's about 30 people in your IED class, $25 times 30 people, or let's say $30 times 30 people, that's $900 just to build the puzzle cubes. And then if somebody should happen to lose one, we're going to need more. They're not sticky, that's another disadvantage. They would require two-sided tape in order to put them together and make them stay together. But they are very stable because they're very rigid. The centimeter cubes are cheap. They're cheaper than buying dye. They are reusable. And they're not sticky, but they are interlocking because they have this little notch on the sides that can be put into this hole to make them stick together. And they do have very precise geometry. Foam blocks are what we're using here, or wood blocks. These can be expensive. They are reusable. They will require some two-sided tape or some glue to put together. They could fall apart easily, and they do offer imprecise geometry. Because they're foam, they're a little bit squishy, so they can see that they might be distorted on the edges. And sugar cubes. How about if we use sugar cubes? They're very cheap. You can buy them at the grocery store for super inexpensive. They are readily available. You can get them at any grocery store. They would require glue because I don't think double-sided tape would be strong enough to hold them. They do have these messy granules that are going to fall off and change the shape as you work with them. Pieces of the sugar will fall off of the cubes. But they do have fairly uniform geometry. It's kind of in the middle of precise versus imprecise. So let's consider what criteria do we need to consider to pick which of these materials would be the best in our decision matrix. So I'm thinking cost is a big factor. We're all in the public schools, and we don't have lots of money to be buying the cubes in order for you to build your puzzle cube. So we want to keep cost at a minimum. Reusability, it would be nice if, because that way if I bought extras, I could put them and they would save until for the next year, and so other people could use them. Or if I accidentally take too many, or I make something, or I make a puzzle piece, I glue something in the wrong spot, how easy it is to take it off and put it in the right spot and reuse it. The geometry is going to be really important for us. If we want the cube to fit together, then we're going to need the blocks to be uniform. Otherwise, we're going to have parts that are too loose or too tight, and then that's going to create problems with our cube and trying to assemble it and take it apart. We do want to be clean. I like to live in a clean environment, and so we don't want to have a mess all over the computers and the keyboards and the classroom. We need to keep it as clean as possible. Resilient means people are going to be playing with these puzzle cubes, trying to put them together and take them apart. So are they going to be able to put them together and take them apart multiple times without them falling apart or getting distorted? And that kind of falls along with testability. How easily is it going to be able to be in order to test these, to put them together and take them apart multiple times? Other criteria that you might consider would be their function. Do they function to make a cube? Manufacturing costs, sometimes not, especially in this example, but sometimes when you're trying to create a design solution, you need to keep the cost of manufacturing the product as at a minimum so that you make the most profit when you sell it. Development time, how long it takes to put them together. The size is often important. How much the material will cost, which we've already talked about that. Safety, is it safe to use them? So you may have to pick your criteria based on what is safe. Okay? Now, when we meet, one of the criteria that you should always use is, does it meet constraints? You will always be given a design brief that details for you what are the requirements of the project, what limits do you have to meet, and you always want to have a thing about meets constraints on your decision matrix. So let's talk about how do we develop a decision matrix. So we're going to take the criteria and take our ideas and kind of put them into a spreadsheet, but then we have to think of a rating system to kind of to be developed to rate the categories on how well they keep the cost down. If having a low cost is important for our criteria, I need to be able to rate on a scale how well this particular item keeps the cost down. There are several different ways that you can do this. You need a ranking scale. Some people do 1 to 4. I personally like to do 1 to 5, so that way if I'm not sure it's good or bad, I always have a middle number 3 in order to rank it. But in our example here in the PowerPoint, it's from 1 to 4. You get to decide, is 1 the best or is 1 the worst? So you'll pick either 1 is the worst and 4 is the best, or you could choose to make 4 the worst and 1 the best. It's up to you. It's really your idea. You have to set this up how you want people to take your survey. And then some things will have yes or no. Is it safe? Or does it meet the criteria? Yes or no. In this example, we use 2 for yes and we use 1 for no. I know that some teachers prefer to use 0 for no. If it doesn't meet the criteria, then we don't want to award any points. And if it does meet the criteria, we want to award 1 point. But there's still just 1 number difference between them, so I guess it doesn't really matter. So you can choose whether to do 0 and 1 or 1 and 2. Setting up the decision matrix. This is what a decision matrix looks like, and there's a template on Blackboard that can help you if you want a nice neat one like this, or some students just choose to draw the table in their engineering notebook. So you can choose whichever way you like best, and at the end of this presentation I will show you where you can find the template on Blackboard. Notice on the side over here, here are my ideas. These are all the things we were going to consider using for the puzzle cube. modeling clay, caramel cubes, dice, interlocking centimeter cubes, foam cubes, and sugar cubes. These are the things I'm considering making my puzzle cube out of. So what are some of the criteria that I feel are important in making my decision? So definitely we've already talked about cost is definitely important. And reusable. Is it reusable? Can I, if I make a mistake, how easy is it going to be to take it off and put it back on somewhere else? Uniform geometry is also going to be super important because we want the blocks to all be the same shape and about the same size so that when we start putting them together in pieces, we take those pieces to put together as a block, they will fit very nicely together and they will not get stuck or be too loose and fall apart. Self-adhering, and you need to decide if this is important to you or not. Is it important that they stick together on their own, or is it okay that I need glue or tape to help them stick together? Cleanup needed, because we said cleanliness was important. So am I going to have to clean up after I use these? And this is going to be a yes or no question. So we'll use this scale over here. Model resilience. How well will it hold up? If we drop it, is it going to fall apart? If people use it over and over and over, will it still stay together in the same form and be a good model? And then testability with other parts. Is it going to be testable to be interlocking the two parts together over and over? Kind of, in my opinion, I would put these two together. But are we going to be able to test it, and will the material hold up while we test? Okay, so these are the criteria that we have decided are important for us in deciding which one of these ideas we're going to use. And then notice down here at the bottom, we have a ranking system. You should always put your ranking system on here. Not everyone chooses to do 1 is worst and 4 is best. Some people choose to do 1 is best and 4 is worst. And then they'll be looking for the smallest total over here. But that's up to you and how you set it up. But you should always include your rankings so that when you start to do your survey, you know what your choices are down here. So now we're going to start trying to take the survey, if you will. We're going to look at modeling clay, and we're going to consider cost and decide what's important for the cost, how I'm going to rank. So here's how I'm ranking the cost for each of the items. We said modeling clay was relatively inexpensive, so I gave it a 2. The caramel cubes are inexpensive, but more expensive than clay, so I gave them a 3. Dice are, I'm sorry, I said that backwards. The caramel cubes will be cheaper than the modeling clay and more easily available, so I gave them a 3 because that's best. The dice were super expensive. We talked about this, so I gave it 1 as going to be worst. It's going to be one of the most expensive options out of this list. Interlocking centimeter cubes. For those, they are relatively inexpensive, and so I gave them a 4. Foam cubes are somewhat expensive, so I gave them a 1. And then sugar cubes are super inexpensive and easy to find, so I gave them a 4. So let's talk about reusable. What would we rank things if they were going to be reusable? So if I were going to try to reuse the modeling clay, that would be okay. Is it reusable? And it's got a question, so this is yes or no. Could I reuse modeling clay? Yes, so I gave it a 2. Caramel cubes, not so much, because as you start to hold on to them, they start to melt and change their shape, and it makes them a little less reusable. So I put 1 no, and I'm less likely to reuse them because I'm probably going to eat them instead of hanging on to them for the next year. Dice, yes, definitely, totally reusable. So I'm going to pick 2 for yes. Interlocking centimeter cubes, totally reusable. Foam cubes are reusable, so that's a 2. And then sugar cubes, yes, they're reusable, but I don't know that they would save for a whole year until next year when we could do this project again, and so I gave them a 1 for no. So let me show you how I ranked uniform geometry. Again, it's not a yes or no question because they could have some uniformity and not totally uniformity, so I ranked them using the 1 through 4 scale. Self-adhering, yes or no. Yes, modeling clay will be self-adhering. Yes, caramel would be self-adhering. Dice is not, so it has a 1. Centimeter cubes, yes. Foam cubes and sugar cubes, no, so they got a 1. Cleanup needed. Now, why this PowerPoint used 3s and 4s, I would be doing yes and no, but I guess they decided that there would be more cleanup for modeling clay than for sugar cubes. So they used a ranking system instead of yes or no. Here's model resilience, testability with other parts, and then after you rank all of these based on each category, and it is a good idea to rank all of them against each other in one column. Rank them down instead of ranking them across. It'll be easier to compare one to another and get your numbers right if you're comparing them all based on one category. Then after you have them all ranked, let's work across the row to add up the totals. In this example, 4 was the best. So if it was really good at something, I would have given it a 4, which is higher than the other choices. So I'm going to want to pick the one that has the highest choice. So this is 22 is obviously my highest number, and so I'm going to choose to make my cube out of interlocking centimeter cubes. This way, my design decisions are based on analysis and not my personal opinion. Like we said, not my bias. I might really want to make them out of caramel cubes because I like to eat those, and I would like to eat some while I'm making my puzzle cube. That sounds fun. But it may not be the most cost-effective and the best idea, because what if I eat too many and then I don't have enough to make my puzzle cube when I'm done? That would be bad. So the decision matrix is a tool that helps you to make these decisions and to keep your own opinion out of it. It can be used multiple times throughout the design process. For example, we used this to figure out what to make our puzzle cubes out of. I'm sorry to say that Tulsa Tech has not bought interlocking centimeter cubes, so you will be using wooden blocks to make your puzzle cubes. But then the next decision we need to make, we may use a new decision matrix. For example, which solution we should choose, which is what you're going to be doing in today's assignment, is using a decision matrix to pick which solution, which puzzle cube. You should have 2 solutions drawn out. You're going to pick which one you think you want to actually build, and your decision matrix is going to help you. We don't just look at them and say, hey, this is the one I want. We actually use a decision matrix to make that decision for us. I cannot stress enough how important it is to use the decision matrix to base your opinions on logic. A lot of times we get caught up in our idea or one certain idea, and that we don't see other good ideas around us. And the decision matrix is really what we use to flush those out for us without our own feelings or without our own opinions tied to it. This will save you with troubles later in the project if you already consider if it's easy to build or hard to build. Then you won't get 3/4 of the way through the project and decide, oh, I shouldn't do this because this is going to be too hard for us to build. If that's important to you, having materials that are easy to build with, then that should be something in your criteria, and you should account for it ahead of time, and it will save you time in the end. Now I want to show you there is a template that you can use. Again, you can just draw these decision matrix grids in your engineering notebook, but if you want, some people like a cleaner look, you can go over here to the design process button, and if you go to step 2, generate concepts, the decision matrix template is right here, and you can save it to your computer, and then you can edit it and put in your own criteria and your own ideas, and then you can print it off for filling out, or you can even fill it out on the computer. But this is where you find it on Blackboard, is in the design process button, and then go to step 2, generate concepts, and you'll find it in there. So hopefully this helps you figure out the importance of a decision matrix and how to build one, and now we're going to give you a chance to try. Thanks for listening.